Greetings. In this video, we will be customizing our terminal environment by creating our own bash prompts. To do this, we will be creating our own bash RC file to replace the default one that came with your distribution. Now, I will be the first to admit that for most people, this is going to be a bit on the esoteric side. Customizing one's terminal is not as appealing as customizing one's desktop, and I suspect many people do not really care as they are not in the terminal that much. Interestingly, a number of people I communicate with find that the more they learn about the terminal, the more they use it on a daily basis. They use it to automate any number of repetitive tasks or accelerate tasks that seem for some reason to take forever on a desktop. And if one uses the terminal, one might as well feel comfortable in it. So this video will hopefully be a step in that direction. So, while terminal emulator is probably the more correct term, most drop the emulator part, making it a bit shorter. So starting at the beginning, when one installs a Linux distribution, there are a number of factors that can affect how your terminal looks and behaves. This is unavoidable as distribution maintainers generally have different ideas about how things should be done in Linux, and only the vaguest of ideas about how you're going to do something in your own setup. So the default terminal configuration tends to be both conditional and generic, I guess is the best way to put it. In an earlier video, Terminal Linux, Console Shell, and Terminal was the title. I should put a link up in the corner someplace. We obviously talked about the different consoles, shells, and terminals. These all can affect how your terminal looks and works, and behaves for that matter. Hence the need for a somewhat generic and flexible terminal configuration at the distribution level. Well, technically it's terminal configuration and shell configuration. And well, yeah, there's a lot of configuration files. However, once one gets down to the personal level, that's you and me, you know what your terminal environment should be like. At least I hope you have some idea. And you are in the best position to determine what you want and need. I want to note that I am using the Bourne Again shell, or bash for short. This is a new version of the Bourne shell, which was represented by just sh, bash. Well, you can get the how they condensed it. This, or one of its variants, is the most common shell that most distributions install by default. If you're using a different shell, then some things discussed here will not match up exactly. There are also multiple configuration files that come into play, both global and local. Your shell has its own configuration file, and your terminal also has its own configuration files. For example, Xterm's appearance and functionality can be configured via Xresources, while the appearance and behavior of the bash shell can be configured via the .bash rc file in your local home folder. Note the overlap here in appearance and behavior and configuration. They do interact somewhat. In this video, I'll be working with Xterm, one of the original terminal emulators. It'll be on a Debian 12 environment. My focus will be on the .bash rc file. I believe the RC stands for run command, I think. If someone knows for sure, please let me know. What we will be looking at is customizing the bash prompt specifically. I plan to do accompanying videos on some of the other things you can customize via your bash shell, and at some point in the future I also want to touch on Xresources and configuring Xterm. This seems to be a gap for a lot of people, and I don't know, depending on how Wayland goes, this may or may not go away, but as of right now it's still out there. So stay tuned for those. Now on to our video. Let's start with a couple of shell startup parameters as they determine how the shell functions in the terminal. Remember, the shell is separate from but runs in the terminal. The two parameters we want to look at are login and interactive. Generally, most users will be using an interactive non-login shell. Some examples will help. When you start your system, you usually drops into a login non-interactive shell. That's when you see a bunch of that stuff going across your screen from top to bottom when you first start up before the logos or stuff appear. If you connect remotely via SSH or some other means, you will be dropping into a login interactive shell. Key here being you have to actually log in to use it. If you're doing a lot of scripts, these usually run in non-interactive, non-login type shells, which don't require any interactions from you. And if you just open a terminal on your desktop, it's a non-login interactive shell, which is probably what the majority of us use most of the time. The main difference is the startup files used, as well as how some conditional statements are handled within the configuration and startup files as well. For the purposes of this video, we will be discussing shells running in terminals as opposed to consoles with no GUI. I mention this because while most things will work the same, there are some differences. We're going to assume that the global configurations of your shell can be found in the etc directory in the files bash.bashrc and profile, both in the etc directory. We're also going to assume that all local customization files that we use are going to be in our home directory, which would be at /home/ your username and then .bashrc. There is also a .profile as well, but we'll be focusing mainly on the .bashrc file here. And we're focusing on configuring it for a interactive non-login shell running in a terminal. Remember, this is a hidden dot file, so you will have to enable show hidden files in your file manager, or probably use the A option if you're using ls in the terminal to find it. Default bashrc files can vary significantly between distributions. For example, the bashrc file in the default Debian distribution is about 3.5 kilobytes, whereas if you have a default Arch installation, the default bash file is about 175 bytes, I believe. Believe it or not, the difference is mainly philosophical. Debian tries to anticipate different setups and different needs and uses a lot of branching instructions in their bash.rc or their .bashrc file. Arch, on the other hand, assumes you know what you're doing and you know what you want, and you will modify a very basic and simple .bashrc file for your situation. Also note, one can delete their local bash configuration files and the shell will still run with a basic global configuration. I'm using my webcam here and I'm trying to figure out how to look at it and it just doesn't look right. I don't know. Anyway, onward. Before doing any configuration, we need to determine some information about our terminal. Let's take a look at some of the terminal shell variables that you will want to be familiar with. The first one we want to look at is the $. Your terminal or shell variables will all start with the $, and then whatever comes after that is the name. The dash is for the flags the shell starts with. These can modify your shell behavior in various ways. The one we are interested in is the I flag, and it'll show up when we do an echo $, and I means we're running in an interactive shell. Path or $PATH is another variable you'll use quite often or want to be familiar with. This is basically where your shell will search for things when it needs to find stuff. Usually when you're launching a binary, this lists the directories it'll look in to find it. You can actually modify this, add additional directories if you want to. That's for a later video though. Next, we want to determine what type of shell we're actually running. I assume you know this, but if you don't, then there is a shell variable for it, a $shell, which is appropriate, I guess. Hopefully this will tell you that you're running the bash shell, and it'll indicate that it's in the bin directory, so it'll give the full path. Next, we want to take a look at the actual terminal type, and this is not like a console and KDE or GNOME terminal. This is going to really specify the color depth of our terminal. It's in the $term variable, and it's going to hold the terminal type being used. In our case, we'll be using an Xterm-256 color. Though it could just as easily been Xterm or Xterm 16 color or something like that. If you're running a strict console with no GUI, it'll probably come up as just Linux. For the purpose of this video, I am assuming we are in a bash shell, and the Xterm 256 indicates a 256 color terminal, which most modern systems terminals should support 256 color mode. If you are running a straight text console, no GUI, like I said, the term variable will probably come up as Linux. If the terminal emulator type is anything other than a 256 color, we could modify that in our .bash RC, which we'll cover later in the video. Mine does show up as a Xterm-256 color, so it's fine, but we'll still go through what you need to do to modify it. A common configuration option is to set the PS1 and PS2 prompts. These are the main prompts you're going to be using in your terminal. There are actually 5 prompts, PS0 through PS4. Like I say, of these, PS1, PS2 are the most commonly used. The other prompts tend to be a sort of custom case thing. So we've got PS0, which is displayed after commands but before output. I've never actually used this prompt. It's actually unset. We have PS1 to follow this up. This is the primary prompt for display before each command. This is the one you normally customize and use. PS2 is called a secondary prompt, and this displays for multi-line commands. Again, commonly used, not as common as PS1, but you'll see it from time to time. And then PS3 displays for bash select built-ins. I've actually never used this one, and it's unset also. And then PS4 display for debugging bash scripts. I've used this on occasion. It is set to a plus sign, but for most general bash use, or most general terminal use, you're not going to be setting this, or you're not going to see this, so it doesn't matter what it's set to. The prompts are shell variables, which you can check with the echo command like we did the other shell variables. Temporary changes can be made to these commands with the export command. Well, technically, you can just set the variable equal to whatever you want, but that's just going to be a local setting, and if you go to subshells or other shells, it might not carry over, whereas if you use the export command, it's more of a global setting and should apply pretty much anywhere. If you want to make a permanent change, you need to make a change to the .bash RC file by adding what you want the configurations to be, and again, I suggest using export to make them global. The prompts are stored as alphanumeric strings, including some symbols, escape sequences, ANSI escape sequences, which are a bit more complex and involve multiple elements than regular shell escape sequences. I'm not sure that's actually correct description, but the ones I'm referring to as shell are simple escape and a character, whereas the ANSI ones are longer. You'll see. A couple examples of shell escape sequences are user and host. So \u will escape to the username, and \h will escape to the host name. They'll be expanded respectively. All escape sequences begin with the \/ character. Some of the more complex escape sequences involve colors, which we'll be using in our effort to customize the various prompts and make them a little more interesting. I should note that how this works will change depending on the color depth of your terminal. This was something that got me for a while until I figured it out. We'll be focusing on the 256 color mode. We will mention 16 color mode, and we'll mention true color, even though we're not going to use either of those. But, well, we'll do a test in 16 color, but just be aware that different color modes do colors differently. They couldn't all be the same after all. First, let's look at shell escape sequences. These are the / followed by a single character. This should be a list appearing on your screen of some of the more common ones. These are not the only ones. These are just the ones you're likely to run into more often than not. As mentioned, ANSI color escape sequences are a bit more complex. Let's cover the basics before moving on with them. First, the escape sequence, multiple characters. For changing color, starts with a / and then an E. You're using an alpha escape sequence. It can also be represented in decimal as a \033 or as a hexadecimal by \x1b. If your terminal doesn't recognize \E, you can try one of the other twos. Generally, in terminals displaying less than 256 colors, the color is represented by a number. The form is \E, the color number M. For example, bright red foreground color would be \E, I forgot to say the left bracket. Yeah, you need the left bracket in there, and then the 91 is the actual bright red color, and M ends the sequence. A bright red background color would be a \E left bracket 101M. Don't forget that left bracket. I forgot it in my initial. I'm not going to go back and change it, but yeah, you need that left bracket. Between the left bracket and the M is your sequence for color. Note that in any color mode, you can use a \E left bracket 0M to reset everything back to default colors. Additionally, there are codes for various text effects. For example, the \E left bracket 3M sets the text to italics. That's assuming your terminal font supports italics. For the 256 color terminals, things are a little different. The escape sequence looks like this. You have a \E left bracket and then 38:5:, then your color number, then M. The 38:5: indicates it's a foreground color. If we replace that with a 48:5:, that indicates a background color. As an example, bright red foreground color is \E left bracket 38:5:9, which is the color, and then M. And a bright red background color would be \E left bracket 48:5:9M, where 9 is the background, or is the color you're doing, and 48:5: indicates it's a background. Got that all out. Good. Here is a website link you can go to try out different colors for foreground and background, along with seeing what the escape sequences look like. I find it helpful when you're trying to figure out how you want to color your prompts. You may or may not, but check it out anyways. As I said, we'll mention true color, but I'm not going to touch on it. A lot of terminals don't support true color mode, but it's basically different in that you have I got to look up what the numbers are that indicate true color mode, but they're usually followed up with the RGB colors. Video on computer colors should be something I need to think about too. But yeah, they usually use 3 RGB numbers to set the color in true color mode, but we're not going to really be doing much with that. Okay, to get you started and to keep you from searching the web, here is a listing for 16 color mode of the foreground, background numbers that represent these colors, and the rough approximation of the color. This varies from terminal to terminal. On the right, you're going to see some common text effects and their corresponding numbers. Again, this is just for your reference. You can come back to this and look at this particular section of the video or make a screenshot of it to have these in front of you when you're playing around with your prompts. Next, also here is a listing of 256 color terminals. Note the 256 color scheme was designed so that the first few colors would be somewhat compatible with the older color scheme, and then they added the grayscale. Otherwise, there is no real rhyme or reason to how the rest of the colors were laid out and numbered. At least nothing related to the actual colors themselves. These charts are easily found online, and in fact, there are several scripts you can find that will generate them for you. So again, nothing unusual about these. I'm just putting them here for your reference. Quick note here, since the prompt variables are stored as bash variables, we can, as mentioned earlier, examine them and change them on the fly. The echo command will allow us to view them, and the export command will allow us to change them. Let's first look at some of our configuration files. We can find the global ones that apply to all users in the etc directory. Again, it's going to be bash.bashrc and profile. There's a couple others in there, but these are the 2 main ones. Just a quick look at the coding in them. We're not going to go over them too much. Then let's jump over to our home folder and our local configuration files. And again, this is the .bashrc file and a .profile file. And most of our attention in this video is going to be on the .bashrc. Note these are hidden files. You either have to set show hidden files in your file browser or use the -A option with the ls command in a terminal to see these files. As also mentioned previously, one can set bash variables without the export command. However, they are only local, and if you want the changes to be available to all spawn processes, then you need to use the export command. It does not make much difference in what we will be doing here, but when we get to making permanent changes, we will want to use the export all the time in our configuration files just to make sure everything's globally available. Let's go ahead and walk through some of the variables we talked about earlier. Let's look at the echo $dash. The variable holds the shell flags for what we are doing. We are interested in the small I, which indicates the interactive terminal mode. Echo $path. This is a shell search path when we're looking for commands. It holds all the directories that the shell is going to search by default. You can see them here. They're either bin directories or game directories. Again, we can add using export path equals path plus whatever we want to add to it. Format's pretty simple. Let's look at the echo $shell. This holds the path to the shell executable as well as the executable itself. In this case, we can see it's bash, and it's located in the /bin directory. So /bin /bin /bash. And if we echo the $term, this is a terminal type, and we can see ours is set to xterm-256 color. Again, we will be looking at how you would set this if it's not set to this in the .bashrc file a little later. We can also echo *ps1, echo *ps2, the two most common used prompts. We can examine their content before we change it. Note we are only making temporary changes at this point. Said changes will go away when we restart our terminal. So here's one. Let's do an export PS1. Note you do not use a $ when you're exporting. Equals and in quote, single quotes, \$, and now we'll echo $PS1. This is probably the simplest PS1 prompt you'd want. Just a simple indicator of whether the user is root, admin, which would be a $, or just a regular user, which would be a $. $, could also, if you don't know pound, it's hash mark. It's the little tic-tac-toe board thing. Why would you want to use a simple prompt like this? Well, it gives you a lot more line space for your commands as it doesn't take it up. I mean, when we start adding things to the prompt, they start taking up characters, and then you have less characters in your terminal to use for your commands, and some commands can get rather lengthy. Generally speaking, though, most users are going to want a little more information in their prompt, so let's make some more changes. We can put the directory we're in, but again, if you need a short prompt, you can use a $, and you can always use the pwd command to find out the directory, but let's go ahead and add it to the prompt. So we'll do another export, PS1 without the $, and we're going to use a left bracket, a \, a small w, and a right bracket, then a \, and our $. We've got some spacing in here too. Then we'll echo the prompt. We can see what this looks like. This is a bit more complex looking, but we have simply added square brackets around the escape sequence for the directory path. However, if we are to deep dive into our directory tree, say we go to user, share, icons, high color, scalable, we rapidly run out of available space in our line. Not that multi-line commands are not a thing, they just tend to be a bit hard to read and they look a little messy. Let's assume we will know where we are simply by the directory name. A capital W, if we replace a small w, only displays the directory name without the full path, so this shortens things up a little bit. Generally, most alphanumeric characters without a \, will just be printed, and this includes things like the left and right brackets and the colons and the @ signs. So let's go to the version of our original prompt by dropping the change root stuff. If you're using change root on a regular basis, you will know it and are probably way more advanced than this tutorial. So generally speaking, for what we're doing in our target audience, you're not going to be using a lot of change root. So the basic command for the basic command here, we're going to export the PS1 equals and then or \u for username, @\h for host, colon \W for directory, a space, and $$ space. Now we can get a little more complex by using ANSI color escape sequences. As mentioned earlier, there are a couple of different types of ways to do color, but we will be focusing on 256 color method here, as currently it seems to be the most common color mode for most terminals. I will note that the 16 color method will work in 256 color. I just don't want to confuse the issue by giving two methods. Well, I guess I will, but yeah, don't get confused between 16 color mode and 256 color mode. Note that, again, these are temporary changes. We can revert it by closing the terminal or using the exec bash, which basically restarts the terminal. And again, that'll get rid of our temporary changes. All right, let's talk 16 color here. We will again be using the export command and the echo command to examine our prompts, but we're going to be going to make them 16 colors. You can go back in the video and look at the chart for the 16 colors and also the chart for the text modifications if you're confused about the ones we're using here. So for our prompt, let's go export PS1 and we'll do the \E, the left bracket, and we'll use 92M, and then we'll reset it with the 0 in, with the \E left bracket 0M. You know, I'm going to start leaving out this \E left bracket. It's the same always. And this will give us a green prompt. And note, if we remove the 0M, the \E left bracket 0M, then our actual terminal output becomes green as well. So let's put it back in. Now then, let's give ourselves a background color. So we'll use the \E left bracket 41M, which should give us a red background color. Pretty cool, huh? Okay. Now let's add a text decoration or fancier text. So \E, left bracket 2M, that wasn't what we wanted. Let's redo that. Let's make it 3M. There we go, italics. All right, you can see this is rapidly getting to look kind of complicated, but again, look for the \E's for the and the M's for the control character sets, or the escape sequences, I should say. Look for the \E, left bracket, and the M for your escape sequences, and then like the \U, \H for your normal stuff. Let's make it blink here. This can really be annoying, okay? If you want to annoy people using your computer, make their prompt blink like this. That's the \E left bracket 5M. And if we execute the exec bash, everything's back to normal. Now that we've done 16 color, let's go ahead and jump into 256 color, which is what I normally use. So export PS1, and we've got our base prompt here. Let's go ahead and add a \E 38:5:. If you remember, this is the foreground color, and then we'll give a foreground color of 228 followed by an M, and then we'll reset at the end, and this should give us a yellowish color for our text prompt. Let's go ahead and set italics. So we use the \E left bracket 3M to make it italics mode. And on top of this, let's add a background color. Here we're going to use the 48:5 sequence to indicate a background color. We'll use 52, which is a sort of a brownish red color. And we're not going to make this one blink, I don't think. But here's a trick you can do if you want to shorten this up a little bit. We backspace and just line all our escape sequences together. Don't forget your semicolons. Then they can be one big escape sequence. And it looks a little more complicated. I'd spell them out individually first, then you can do this one, but this is the way to shorten it a little bit. To me, it looks more complicated. I prefer just to leave them all individuals. Anyway, let's clear that and exit. All right. Next, we want to do some permanent changes. So for that, we're going to play with our bash RC file. So let's do an ls tacl from our home directory, and you can see our .bash rc file there. You can see the .profile file. We're not going to be using that one or touching it. We're going to move our .bash rc to .bash rc backup, and then we're going to do a touch.bash rc, and now you can see we have an empty file. Quick note, the .bash rc is not executable. It's read by the terminal, so it's not actually executed. It just sets variables and provides configuration information. Now we're going to use Geany here. It's a graphical text editor. I mean, we could do this in the terminal with VI or Nano or any of the other terminal editors, but I got a text editor installed, so we'll use a text editor. Again, this is Geany. Here's our original bash rc file and our new one, our .bash rc back, and then our new file. So first thing I always do is put a header of some comments in there. I recommend commenting your code as much as possible, at least initially, so you know what the stuff does. Now, next thing I want to do, remember we talked about forcing 256 color mode. We would export the term variable here as xterm-256 color. Since mine already is in 256 color, we'll leave this commented out. Basic hash mark or pound sign turns a line into a comment in a bash in here, in this file. So let's check for our interactive terminal. This sequence in the original file, case in, this is what determines whether it's an interactive terminal or not. If it's not, it exits. We could paste that in and use it. Or here is a quick shortcut tip, and I'll leave it to you to figure out how this works or why it works. This uses some bash built-ins, and it says just a single line, but it does the same thing. So your homework assignment, figure out why this works the way it works. Let's set up a few aliases. Next, we'll cover aliases more in the next video. I'm just going to set these up. Yeah, those should be good. These will just, since we're using color, we want certain commands to display in color. And that's what we're setting up here. Like I say, we'll cover aliases more in a later video. Here's our basic command prompt. Let's add our colors, our PS2 prompt, and then we can execute bash, and you can see that blue's a little too light. Let me darken that up a little bit. Let's look at our table real quick. Yeah. There we go. That's a little better. Okay. And that's how you make permanent changes to your bash shell. Okay. All right, there we go. That was fun. We've gone through colorizing your and adjusting your bash prompt. I hope you found that interesting and worthwhile to learn. If any of you actually do adjust your bash prompts, let me know what you do, how you design them. I'm kind of interested. Whether just simple colors, italics, that blinking prompt, which everybody loves, yeah. But as I said, this is going to be the first video in a couple of videos on customizing your shell or terminal environment. So we'll be going over aliases in the next video, and maybe some of the things like line memory and stuff like that, but mainly aliases in the next video. And at some point I want to do something on X resources. I mean, as good as Wayland's doing, pretty much all the old Windows managers, especially the uh, floating ones, tend to use Xorg and not Wayland, so X resources are going to definitely be around for a while. So as always, please like this video, comment on it, give it a thumbs up. You can follow too, all that stuff. And like I say, the next video I'm thinking going to do aliases mainly, and maybe a few other little things. Depends on how long aliases is. I generally don't like to make these videos too much longer than half an hour or too much shorter, but we'll see how that goes. Anyway, until next time.